Example 10.1. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. So this is our question. First of all, we are going to draw a rough picture putting the values that are given in this question. Okay. So this is our principal axis. A convex mirror is shown here. This side of this convex mirror is rough. This side is reflective one. Okay. So in the question it is said that the radius of curvature of the convex mirror is 3 meter. So we are marking the radius of curvature 3 meter from the origin. Okay. So this is our radius of curvature represented by the letter R. This is origin. Now a bus is located at 5 meter away from the mirror or away from the origin. Okay. So a bus is drawn here which is 5 meter away from the origin. So the measurements that are given in the question are the radius of curvature R which is 3 meter and the object distance U which is minus 5 meter. Okay. So here we can see the radius of curvature is taken to be as positive. Why it is positive? Because it is right to the origin. According to the new Cartesian sign convention, the distances that are measured to the right of the origin is always taken as positive and the distances that are measured to the left of the origin is always taken as negative. Okay, that's why the radius of curvature which is right to the origin is positive here and the object distance u which is left to the origin is negative here. Now the question is to find the image distance first, that is the position of the image, and also we have to find the size of the image or the height of the image h dash. Okay, then we have to state the nature of the image. So first we can find the image distance v. For this we can consider the mirror formula which uses the term focal length. Okay, so first we have to find the focal length. The equation for focal length is given here, f is equal to r by 2. Okay, you have to by heart this. Substituting the value of radius of curvature here, we can write it as plus 3 meter divided by 2. Here the radius of curvature is plus 3 meter, isn't it? So we are substituting the value of radius of curvature here, and by calculating this we can find that the focal length is plus 1.5 meter. Okay, so the positive sign here implies that the focus is right to the origin. Okay, the focus is right to the origin and the value shows that it is 1.5 meter away from origin. So we can draw it here. So this is our focus. It is 1.5 meter behind the mirror. Okay. Now our first objective is to find the image distance v, isn't it? So we have already got the focal length f. Using this f, we can find out the value of image distance or v. Okay. For this we are taking the mirror formula 1 by v plus 1 by u equal to 1 by f. From this, we can find the value of 1 by v. Okay, for this we can take this plus 1 by u to the other side of the equal to sign. Okay, so taking this 1 by u to the other side, we can write this equation as 1 by v equal to 1 by f minus 1 by u. So here this plus 1 by u became minus 1 by u on the other side of the equal to sign. So then substituting the values of f and u, we will get like this. That is, the value of f is already found here, plus 1.5 meter, and we know that the value of u is given in the question, that is object distance, which is minus 5 meter. Okay, substituting these two values, we can write it as 1 by plus 1.5 minus 1 by minus 5. Taking this positive sign to the upper side and taking this minus sign to the upper side, we can write this same terms like this. Okay, so plus 1 by 1.5 minus 1 by 5. So 1 by v equal to 1 by 1.5. This minus and minus together, it will become plus, isn't it? So 1 by 1.5 plus 1 by 5. Now doing the cross multiplication, that is 1 into 5, 5 plus 1.5 into 1, that is 1.5 divided by 1.5 into 5 or 5 into 1.5, that is given here. Okay, then doing this calculation, we will get plus 6.5 divided by 7.5. This is the value of 1 by v. Okay, what we have to find is image distance or v. Okay, so what we can do is take the inverse of this term. We can take the denominator to the numerator side and numerator to the denominator side. Doing so, we can write v by 1 or v equal to 7.5 divided by 6.5. Okay, which is equal to plus 1.15 meter. Okay, so we got the value of v. It is positive 1.15 meter. Okay, so according to the sign convention, we know that a positive sign indicates a measurement which is taken to the right of the origin. So we can mark it in the picture. We are taking 1.15 meter right to the origin, and this must be the position of image. Now we got the position of the image. Okay, the position of the image is found here. Now we have to find the size of the image and the nature of the image. For this, we are taking the equation of magnification. M is equal to h dash divided by h, which is equal to minus v by u. Okay, in this question, the height of the image is not given here. Also, the height of the object is not given here. So h dash and h are not given here. What we can do is we can use this equation. M is equal to minus v by u. Okay, v and u are here, isn't it? So we can put the values of v and u here. V is 1.15 meter. The negative is put here, and the value of u is given in the question, which is minus 5 meter. Okay, doing this, we will get plus 0.23 as the result. So the magnification is plus 0.23. Next, we can take this equation. M is equal to h dash divided by h. The reason behind taking this equation is that we have to find the nature of the image and the size of the image. Okay, so we are taking this equation for reference. We got the magnification as positive 0.23. So the magnification is positive. Okay, and here h dash is the height of the image, which is not known, and h is the height of the object. Okay, we know that the height of the object is always taken as positive because according to the sign convention, any measurements that are taking perpendicular and above the principal axis is positive. Okay, so the object is placed here upwards, and so we can take the height of the object as a positive value. So the value of magnification is positive and the height of the object is positive. Okay, so to satisfy this condition, that is to satisfy the magnification as positive, the height of the image also must be positive, isn't it? So from this we can conclude that the height of the image is positive and so the image is upright. Okay, so we can draw an image upright on the principal axis, which is 1.15 meter away from the origin. We can conclude that the image is virtual because the image is not formed by the converged rays. It is formed from the extension of diverging rays from the convex mirror. Okay, so we can say the image is virtual and the image is erect, which means the image is not inverted, it is upright. So we can say the image is erect and it is smaller in size by a factor of 0.23 because the magnification which is given here, which we got here, is plus 0.23. So we can say that the image is smaller in size by a factor of 0.23. Okay, so we can draw the image like this. The image is smaller than the object, it is virtual, and it is upright or it is erect.